This is from 10.1, number 4. Student had some questions about this problem. The concentration C of a drug in a patient's bloodstream T hours after injection is given by C equals 35 times T over 15 plus T squared. So what is the concentration after 2 hours? So you see the student looks like the student got that one correct. And okay, see if I could change colors, but I'm not sure I can on this. Maybe I can up there. There we go. So it's going to be 35 times 2 over 15 plus 2 squared. It's going to be, I'll put my calculator here. When I'm doing the denominator, I'm putting in parentheses 15 plus 2 squared. And then we get 3.684241%. These want 2 decimals. So boom. Then it says, how long does this drug stay in someone's bloodstream, assuming the drug is out of the patient's system once the concentration has reached 0.06%? So we're going to replace C with 0.06. So 0.6 or 0.06 equals 35 times T over 15 plus T squared. I'm going to multiply both sides by 15 plus T squared. So that will divide out in the denominator. And then we'd have 15 times 0.06, or 0.06. .6, so I meant. Great, where's the marker I was using before? .6 plus 0.6, times T squared equals 35T. So we get ourselves a quadratic here. And now I'll move everything to one side and I'll put it in descending order. Really not happy with that pen size change after I erased. Okay, so it's going to be 0.6T squared minus 35T when I bring this over. And then I have, excuse me, plus 15 times 0.06, 0.6T. That's why I just say, I don't usually do this, 0.6. I get 9 equals 0. Now if you use the quadratic formula, T equals negative of negative 35 plus or minus the square root of negative 35 squared minus 4 times 0.6 times 9 all over 2 times 0.6. If I do that, we get 35 plus or minus. So now we're looking at the square root. 35 squared, negative 35 squared, same thing as 35 squared, minus 4 times 0.6 times 9. And that's going to be 34.69005,621 divided by 1.2. So we have 2 answers out of this. So we have the 35 plus the 34.6900521 divided by 1.2. And then we have the minus. And let's look at the plus. 35 plus this amount. Oh, delete that. Divided by 1.2 So I get 58, excuse me, 58.075 hours. 0.7504684. And the other one would be that 35 minus 34.6900521 divided by 1.2. That's going to be a really small number, meaning not much time has passed. So we're looking at the longer term before it comes out of the system. So this number is going to be right after it gets into the system. So 35 minus this 34 number, and divide that by 1.2, we get 0.25 hours. So that's going into the system. This is coming out of the system. So think of it like this. I'm trying to get down to this certain number here. It's time after they take it. And so coming out of the system would be this 50, here's my x-axis, 58.075 hours. So this is the answer that they're looking for. And then what is the end behavior of the function? So as t goes to infinity, what happens to c? Well, here's our function. If t gets really, really big, the t squared is going to overpower the t. So it'll become something small over something really large. And so it goes to 0. And that's why we get this answer here. Okay, hope that helps.